Good morning to all of you. So today we are going to see rocket motion, this topic, and we are going to discuss about the equation for rocket motion. And before that, we have to consider these two assumptions. First is if g is constant. G is constant. That means we have to consider that acceleration due to gravity for rocket motion is constant. Okay, it is not going to change. Then again, we have to consider that effect of rotation of Earth. Rotation of Earth on rocket motion is negligible, and air resistance, which may oppose the motion of the rocket, that is also negligible. We have to consider these two assumptions. Okay. Now we'll go through the derivation. Now, in this case, firstly, we have to understand about M0. M0, now this is the total rocket in which this part, the blank part is the mass of vehicle. It is vehicle, and the cross line part is the fuel part. Here fuel is filled up. Okay. And this is the mass of vehicle. So mv is the mass of vehicle and mf is the mass of fuel. Okay. And at time t, when t is equal to 0, that means when the rocket is on the earth, when rocket is at rest, that time the mass of this complete rocket is m0. Remember, m0 is for rest mass of the rocket when t is equal to 0. Okay. And what is capital M? Now suppose this rocket, we ignited the fuel. Okay. And few amount of fuel is burned up, and after burning up, what is happening? Large amount of gas is hot gas is generated, and that hot gas will come out from the nozzle of the rocket. It will bump onto the ground, and rocket will move up. Okay, rocket will move up. Now after time t, suppose after time t means after suppose 50 minutes. Okay. After we launch the rocket from the ground. Okay, suppose it reach up to some height at time t after 50 minutes. Suppose it mass will be reduced as compared to rest mass. Rest mass से इसका mass का what is going to happen? Reduce, because mass of fuel will burn. No, when fuel will burn, obviously gas is coming out. That means mass of fuel is reducing. That means total mass is going to be reduced. Mass of vehicle will be remain constant, but mass of fuel is going to change. At time t, suppose that mass is capital M. Okay. Then at that time, after 50 minutes, what is the velocity of the rocket? Velocity of the rocket is v. Okay, v is the speed at time t. Then delta M, what is delta M? Reduced mass of the rocket due to burning of the fuel in further time interval, delta T. After 50 minutes, suppose further time we take 1 minute. So delta T is 1 minute. After 50 minutes, that means 51st minute, what is going to happen? Delta M amount of mass is reducing. This much amount of mass is burned. This much amount of mass of fuel is burned, going to burn. So if this much amount of mass of fuel is burned, the same amount of mass is going to reduce by total mass. Okay, at time delta t. Now delta v, when this much fuel is burned, obviously that much amount of gas is releasing from the rocket, and its velocity is increasing more. How much its velocity is going on increasing? Delta v amount. So that's why this is the second figure you can see. So delta m is the mass of fuel which is coming out of the rocket. It is burning and coming out of the rocket after further delta t time, 50 minutes के बाद, t time के बाद. So at t plus delta t time, the velocity of the rocket is going to be increased by amount delta v. So now velocity becomes v plus delta v. So delta m इतना fuel burn होने के बाद जो push मिलेगा rocket को, वो कितना होगा? So that much velocity is increased. Delta v is the increased velocity at t plus delta t. Okay, now what is happening in this case is generally v minus u, this is very important thing you need to consider. Okay, v minus u. V minus u is the relative velocity of exhaust gas with respect to stationary frame of the gas. Suppose v is the velocity. Suppose v is the velocity of the rocket. Fine, v is the velocity of the rocket, and this fuel is burned and it is coming out from the rocket with velocity u. फ्यूल कितने वेलोसिटी से बाहर आया है, u वेलोसिटी से बाहर आया है. ओके, देन व्हाट इज द रिलेटिव वेलोसिटी? रिलेटिव वेलोसिटी मींस व्हाट? फ्यूल कब बाहर, फ्यूल कुछ वेलोसिटी से बाहर आ रहा है लेकिन रॉकेट इज गोइंग in the opposite direction. Fuel is going in this direction, rocket is going in this direction. So उसकी वजह से उसकी velocity का क्या होने वाली है? V minus u will be the actual velocity, relative velocity of the fuel. इसको समझो. Suppose the train is stopped. Suppose train is stopped, right? And you are jumping with velocity u. Train is stopping, your velocity is u, then your velocity will be u. अगर ये vehicle stop है, वो move नहीं हो रहा है, और तब अगर ये fuel बाहर आ रहा है तो velocity is u. But now what is happening? The train is moving and then you are jumping, so something is difference, right? And that relative velocity is changing. And what velocity comes? So train का जो opposite direction का motion है और हम जो jump कर रहे हैं, that is both the directions are opposite. So relative velocity with the stationary frame, जो बाहर खड़ा आदमी उसको क्या दिखेगा कि उसकी velocity कितनी है? v minus b, मतलब v minus u, जितनी velocity train की है माइनस जितनी velocity actual velocity है, लेकिन जंप करने के बाद वेलोसिटी चेंज होने वाली है, वो यू नहीं रहने वाली, वेलोसिटी इज गोइंग टू बी चेंज. दैट इज कॉल्ड एज रिलेटिव वेलोसिटी v माइनस यू ऑफ फ्यूल. यू गॉट इट? v माइनस यू मतलब ट्रेन जब चलती ट्रेन से जंप करने के बाद जो वेलोसिटी आने वाली है, और जब ट्रेन रुके तब जंप करने से जो वेलोसिटी आने वाली है, इसमें डिफरेंस रहेगा ऑब्वियसली. सो जब चलती गाड़ी से आप जंप करोगे, ऑब्वियसली वेलोसिटी विल बी रिलेटिव वेलोसिटी. रिलेटिव क्यों? क्योंकि ट्रेन की वेलोसिटी के ऊपर आपके जंप की वेलोसिटी डिपेंड है. दैट वेलोसिटी बिकम्स v माइनस u. सो आई होप all the things you must have understand. Okay, now the next thing is this one. The law of conservation of momentum is the law of conservation of momentum. Momentum is mass into velocity. Mass into velocity. So suppose before before delta t, what is the momentum of vehicle? Before further time delta t, डेल्टा टी टाइम से पहले और डेल्टा टी टाइम के बाद का मोमेंटम, ये हमको देखना है. ओके, मोमेंटम बिफोर डेल्टा टी एंड राइट हैंड साइड इज मोमेंटम आफ्टर डेल्टा टी. सो बिफोर डेल्टा टी, व्हाट वाज द मोमेंटम? मास वाज कैपिटल एम, वी वाज द वेलोसिटी. ओके, मतलब जब 50 मिनट्स था तब का. 51 मिनट का कितना मोमेंटम है ये? सो दिस इज मोमेंटम बिफोर 50 minutes and this is, or up to 50 minutes, and this is momentum after 50 minutes. That means after delta t time. So after delta time, ये समझ में? So this is the velocity, this is the momentum before 50 minutes, before delta t. That means at time t, what is the momentum? Mass into velocity. Okay, and now after delta t, what is the momentum? Now m minus delta m, this is the mass of m minus delta m is the डेल्टा एम. इतना मास फ्यूल बर्न हो गया तो टोटल मास में कितना रिड्यूस हो गया व्हीकल के? सो इतना. सो इसलिए m माइनस डेल्टा m इंटू v प्लस डेल्टा v. व्हीकल का वेलोसिटी कितना है? v प्लस डेल्टा v आफ्टर डेल्टा t. सो मास कितना रिड्यूस होगा? डेल्टा m. एंड वेलोसिटी कितनी इंक्रीज हो गई? डेल्टा v. ओके, इतना मास बर्न होने के बाद इतनी वेलोसिटी इंक्रीज हो गई, इसलिए मास इंटू वेलोसिटी. दिस इज फॉर vehicle. Plus now for fuel, what is the mass? Delta m. For fuel, what is the mass? Delta m. And what is the relative velocity? This I already explained you. V minus u. This is the relative velocity due to motion of vehicle. Relative velocity of fuel. Okay, relative velocity of fuel due to velocity of vehicle. Okay, so the mass of momentum of vehicle plus momentum of fuel will give you total momentum, like that. Okay, so mass of so this is momentum before t, before delta t, and this is momentum after delta t. Once again, see, this is the mass minus delta m. Why? Because delta m, this much amount of fuel is going to be burned. So mass reduce होगा इसलिए m minus delta m, and velocity increase होगी इसलिए v plus delta v. प्लस नाउ फ्यूल के लिए फ्यूल का कितना मास है, डेल्टा m, प्लस उसकी वेलोसिटी कितनी है, v माइनस वी, मास इनटू वेलोसिटी. यू गॉट इट. तो दिस इज लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम. एकदा ये इक्वेशन लिखने को आया, बात खत्म. ओके, सो mv is equal to, now just multiply this m with this v, that is mv, plus m into delta v, m delta v, minus delta m into v, delta mv, plus minus delta m plus delta v. Oh, yeah, here we have delta. Okay, here we have delta mv, this one, and here we have delta v. Okay, delta v, and here we will have delta mv minus delta mu. Okay, so this and this will not get cancelled. Oh, we forgot to write one term, delta m delta v, that we forgot to write. Okay, so can we write here?